So, hello everyone, this is Akshay here, and welcome back to the GFG POTD streak of day 161. So, without delaying further, let us start with the today's question. And today's question name is event swap, and the tags mentioned here as arrays and sorting. Let us read the question. If you have read the question and able to solve it, then well and good. Let us read it together and then solve it together. So, we have been given an array A and we need to generate an array B. And what are the constraints that we can apply to generate A to B is that you can apply any one type of operation on the A, right? There is any number of times. In one operations, you can swap AI and AI plus 1. Okay, so you can swap the adjacent elements only if the sum of those adjacent elements is even. Okay, an array B should be generated after applying above operation any number of times. Okay, and it should be lexicographically the largest among all the subarrays that can be generated from array A after. Okay, so you can apply this operation is mentioned here. You can apply it any number of times, and that operation is nothing but you can swap the next adjacent element, right, if the sum of those adjacent element is even. Okay, so let us first clarify कि lexicographically sorted क्या होता है. So let's say you have these arrays given, right, 1 3 and 5, and let's say you have 1 5 and 3. So I can say that this is lexicographically greater than this the above one. Why? Because you can see that the first two integers are common, but you can see at the second integers, the second array list, or let's say list, and second element of the second array is greater than the second element of the first array. So that's why it is greater. Similarly, you can compare with another, let's say 315, right? And let's say you have 415. So definitely the first element itself is written, so this will be greater, right? Okay, so that is the meaning of lexicographically sorted. We have discussed it multiple times. So हम यहाँ क्या कर सकते हैं? So let's say we have the element as 135. So can we, using the brute force technique, तो यही बोलती है यार कि form all the this possible sub arrays or sub list if possible, and then just return the largest one, right? So let's say if we are able to form all these sub arrays, or what to say, all the possible list, then we will make a 2D list, right? And you will add each and every list there, and we will sort this 2D list whatever in descending order using collection dot reverse, and whatever comes at the top we will return that is. But is it possible to form each and every list? Would that be too complex? Because forming the sub arrays just requires n square. We just run from I equals to 0 to less than n and j equals to I to j less than n. But can we do something like that here? So let's say we are at this point and you can see that the adjacent element sum is even. So let's say we swap this thing 3 1 and 5. Similarly, when we go for the second element, right, and because we cannot compare this first element to the last, because we can just compare I and I plus 1, right? So now we are, let's say we are this element, and you can again see that 5 plus 1 is 6. So let us swap again. So 3 5 1, right? But there are much more possibility, right? You can see there is 153, there is 315, we have found 351, there is 513 and 531, right? So can we do something? Can we do, let's, we started from this pointer, right? And then we iterated for the next element. तो देखा जाए तो यार ये बहुत ही complex है, like complex in the sense there is no single rule of traversal. I don't think there exists a single rule of traversal to form using this subarray, using this array to all the possibilities of arrays using a brute force technique. Either use n square or n cube, right? So that if even if it is, that would be complex. So while I was thinking for this approach, तो मेरे को लगा यार कि हमें क्यों ही करना वो काम, वाई टू फॉर्म ऑल द सब लिस्ट, बिकॉज मैं ब्रूट फोर्स से पढ़ाता हूँ, शुरू करता हूँ, इसलिए मैं सोचा कि करके दिखा दूँ, बट स्टिल दैट वुड बी वे टू कॉम्प्लेक्स टू कोड, है ना? आप ट्रैवर्सल में देख लो, या पॉइंटर मैं कहाँ ही रखूँ अगला पॉइंटर की, तो ये सारे लिस्ट फॉर्म हो जाए, राइट? ओके, सो ठीक है, सो वो तो था यार कि वी शुड हैव स्किप, वो स्टेप को छोड़ते हैं. तो दूसरा जो लॉजिक और इंट्यूशन यू कैन से इज that let's say you have 1 3 and 5, right? So you can clearly see that this can be swapped, right? And then you can clearly see that this can also be swapped, है ना? So why not keep track of the range where the swapping is possible? So let me write it for you. Keep track of range where swapping is possible, right? And if the swapping is possible, then for that range you will just sort it in descending order, right? So let me write it, descending order. So what I'm saying is, let's say we are doing for 1 3 5, right? Okay. So for 1 3 and 5, you can clearly see that if I am this pointer, I can clearly see that the next adjacent element is uh, satisfying the constraint of swapping, right? So I'll be at this pointer now, and I will see that the next element is also satisfying the constraint of swapping with 3, right? So, and there is no more element, so my range will be 135, and I will sort it in descending order, that is 531, and I will get my answer, right? That's the answer. Let us do the same thing for the second case and see that if C is fit or not. So it is 1 3 and 4 2. Okay, so 1 3 and 4 and 2. So my first pointer will be here and my second would be here, right? We can see that the sum is even, so we can swap it, right? So my I will be here, and then this J, you can clearly say that it can swap it, right? Okay, then J will move here, right? This is the third element, and you can see that now this J and the adjacent one, right? So this and this can be swapped or not, right? Why I'm checking with J and J minus 1, because it was saying that if you are, let's say if you are comparing this 3 element, right? So you have to check it with 4, right? That's what we are doing. We're comparing 1 with 3, and now we're comparing 3 with 4. Okay, so if I'm at 4, I will just see that if my previous element is the sum is even or not, right? 4 plus 3 is what? It's 7, right? It is not, right? So we cannot do it. That means our first range is this one. We have to swap. We have fixed our first range. We need to sort in descending order. So it will be 3 1 4 and 2, right? And then the range will have a start pointer and end pointer, right? So I and J are maintaining that thing. So now my I will be updated to J. My pointer will start from here, right? Okay, I will be updated today, and J will be nothing but I plus 1. Again, I will see that if J and J minus 1, element at J and J minus 1 is both even or both odd. Why I'm checking both even or both odd? क्योंकि sum जो है वो even तभी होगा जब both elements are odd and odd, right? Then only we'll get a sum even. Or if you see that even and even, then only get a sum even. Or you can check कि sum even हो जाए, right? तो आप दोनों में से कुछ भी कर सकते हो. So I can see again that this is the thing. 4 plus 2, the sum is even. So my J will be move ahead, but there are no elements ahead. So my second range of sorting would be this one, right? So now if I sort it in descending order, so it will remain the same 3 1 and 4 2, right? And I have no more elements left, so this is my answer, right? Let us do one more dry run, right? So that you can understand. Let's say there is an element 3 1 4 and 2, right? So the first range will be this one, because 4 plus 1 will be 5. So you will sort it. So it will be 3 1 4 and 2, right? Now the I and J pointer will be here. So you can see that it satisfies the constraint. So the J will move ahead, and now it is out of bound, right? So your second range will be this to swap. But if you not swap, to sort in descending order. But if you sort in descending order, it will again give you the same thing, 3 1 and 4 and 2. Let us quickly verify for the third case which we did at the end, and if that satisfies, then we will proceed here with this logic and code. So it is 3 1 4 and 2. So let us use the compile and run here. It will be 3 1 4 and 2. So 3 1 4 and 2, we got the expected output is 3 1 4 2. Okay. So we are on a good page. So our logic is working. So the only thing is that how we are supposed to code this thing in our uh, editor of defining the range, right? So clearly I can see that I can travel up to endpoints, right? I cannot use a for loop because I is again updated to J, right? At some time. So I is not actually doing just plus plus, it is jumping more than even twice or more than even thrice, right? So I have to use a for loop. I cannot use I have to use a while loop, not a for loop. So while I equals to less than n, I will initialize that I equals to 0, and under this while loop, I will initialize the pointer as j equals to I plus 1, right? You can clearly see for 1 and 3 we initialize the j at 3. Okay. So now I have to see that if the constraint satisfy, then I need to move my j pointer ahead by 1 point, right? Hmm. But in order to find the range, we just have to move 1 pointer ahead, right? So here we can use for loop. Here we can use for loop, and for loop condition will be like this, that for int j is equals to, let's say, not int j, it will be int will be declared here, right? Because we have to use this j outside this nested for loop as well. So do not initialize with j equals, just write int j, and I will say that int j is nothing but I plus 1. J should be less than n, right? And one more condition will be that if array of j %2 equals to array of j %2 array of j minus 1 %2, right? If you're not able to understand this thing, please pause this video and try to think, because I've already written the solution here, right? Yes, you were right. So if the sum is even, then the case will be that both are the odd elements, and if you do %2, if you find the remainder dividing the odd element with with the integer 2, you will get 1 1, right? So that's what we are comparing. For the even, will give you 0 0. So that's what we are comparing, right? Once you do that thing, so the J++ is already doing, so we do not have to do anything in this for loop. So the for loop body will be empty. We don't have to write anything here. And once we did that, so after this for loop, once we did that, we just have to sort the array, right? So you have to sort the array, right? You can use now in Java we cannot use arrays.sort here, right? Because arrays.sort is used for the you cannot use it directly to sort the primitive arrays in descending order, right? For the to sort any list in reverse order, you have to use collections.reverse order, right? And collections.reverse order sort only works only if it's an array of objects, right? It does not work for int is a primitive data type, right? So this if you want to sort this, then you can use arrays.sort, and that sort in just descending order. So if you want to in the reverse order, then it would have been the object of a class, right? So integer, the whole, this is a wrapper class, right? So let's say you have an array list of integer, right? If you declare it like this, array list integer, you give a name al and then you write new array list, right? So that there you can use collection of reverse order. But since this is an array, you cannot sort it directly. In C++, we have the thing, but in Java we do not have, right? So that means we have to make some let void helper function, right? Let's name it at helper function, help sort primitive. Let's name it like this, right? And we will do it, we'll just sort it and we will swap the values, right? Because we want the array in descending order, right? So the board may look messy to you, but just try to bear with the logic part, right? And we will definitely start the coding in very short span of time. So here we will run this helper function of sort, and then what happens next is that we have to update our start pointer of the previous range to I equals to j, right? The start pointer of the previous range to the end pointer of our current range. And at last, we just have to return the array whatever we sorted, because sorting in descending order is at every point of time it is taking care that you will get a lexicographically largest possible list, right? I have showed you the 3 dry runs. So that's the exact pseudocode. I have not mentioned how to write the helper function. You just have to sort it and swap the values, right? It will take 3 parameters, the array and I comma j. Try to code this step in your creator by yourself and then we will resume. Okay, so I hope you're able to code it. If not, let's start it step by step, right? So let me write some skeleton code and then we'll deduce the logic. Okay, so I have written the helper function, that is to sort the primitive data type, that is the integer array, with the int, that is which is declared with int. If the array list would have been made with the integer, that is the integer, that is then the wrapper class, right? So that means it's the array of objects of class integer, integer, not int, right? So there is some limitation in Java as well. So you cannot sort it in descending order by using as.sort, right? Okay, so you have to do this and you have to just swap the values, right? So let us code this thing now. So while I is less than 0, you'll be moving ahead. Or I have showed you the pseudocode already, right? So let me code the entire thing now. So that's the code here. You may pause this video here to try run for yourself as well once more, because it will the result will still remain the same, which I showed you for all the 3 dry runs as well, right? So that's the thing. We do not know that I would be have been updated to j, right? We have to update our current range starting index to the current range to the ending index, right? You are just keeping the track of the range where the possibility of swapping was happening, right? And question says that you have to return in the largest, that is in the lexicographical order. So we are just maintaining that range and sorting it, and that's it. You are done for that particular range, right? Okay, so that's what is happening here. So, and since if this condition satisfied, that is when we are finding the range of the possibility of swapping. So that's the condition here. And if that's the case, then you just have to move one pointer ahead, keep on checking that if more elements can be included or not. So that's why we have used the for loop here. And since the J plus is already happening, so you do not have to mention anything in the body. And if you may remember in the maybe I don't know which day POTD streak, that was a hard question. And there were multiple ifs running without the body statement, right? So I've tried my best to explain that part as well. क्योंकि वो question actually में hard question था. ठीक है, so that is it. We are just sorting it in using the helper sort primitive, right? तो मैं एक बार फिर से ड्राइंग दिखा दूँ क्या कि कैसे कैसे चल रहा है. तो एक बार मैं लास्ट पर दिखा देता हूँ. So video is already 15 minutes ahead, but let's see. So the first pointer I will be here and then J will be here, right? So J will be updated to this pointer ahead, and here the condition will not satisfy, that is 3142, right? So now these two will be swapped, right? Because when you pass the function arrays dot sort I comma j, right? So j is the inclusive and j is the exclusive index and I is the inclusive index, right? So it swaps it. So it will be what sorting this I to j minus 1 in the setting order. So it will be 3 comma 1 and then 4 comma 2. So I will be updated to j now. So I is here and j is nothing but I plus 1. So it says the condition satisfies. So j will be again pointing to one pointer ahead, right? And then it's out of index. So again this and this will be sorted now. Will be passed to sort. And if you sort it, the still the array remains same. So 3, 1, 4, and 2. So this is the answer, right? Okay. So let us compile it and do it. And why while swapping, why I have done j minus minus, because I already explained you the j is nothing but the exclusive index, right? That part is not getting sorted. Okay, so there's something that I have written here, why I less than n. So there's a problem. I should be less than n, not less than 0. Okay, so that's the compilation successful. There was one bracket error as well. There was one duplicate brackets at line number 48. So that has been solved now. And you can see the compilation URL principal don't matches. So what would be the time complexity of this code? That we are visiting each and every element using this for loop and this while loop and for loop, right? And when we got a range, we are sorting it. So that means this while and for loop is overall in totality is running for visiting each and every element just once. So that is O of n, right? But in the meanwhile, when we find a range, we are swapping it. We are swapping the range, right? So and in sorting, you get the time complexity as NlogN, right? Right. So but that sorting is happening in parallel of this for loop, right? So that means it will be O of n plus, and we are doing it for n log n. So the worst time complexity will be n log n, right? Right, because this for loop is responsible for visiting each and every element, and this is responsible for sorting, and both are the parallel work, right? So the worst case, so the more time complexity is required in this line number 44, that is n log n, and this line 40 is just O of n. So it will be the worst will be O of n log n. What will be the space complexity? Since we are not using any array or sort, we are just routing some variable, so that will be O of 1. So that's also mentioned in this expected, right? Let us hit the submit button, and then we'll see for ourselves. So when it gets submitted, we'll move to the C++ code as well, and you can see that this helper function will not be required in the C++ because we have uh, the sorting function to sort the primitive data type as well. So that's it. The code has been successfully submitted. Let us shift to the what to say the C++. So let me just copy this part of code, right, and we will move here, right. So instead of array, it is A. So I will just say A. I will remove the both RR here, and I will just say A, and I will comment down this function, right? And the C++ user now may be able to relate more what I am about to write. So I will say now I have to just to sort, that is from I to J, right? So I will say that A dot begin plus I, and then A dot GIN plus J, right? I have given the interval, and this greater is indicating that you need to sort it in decreasing order, right? So that is it in C++. There's just one line, and you can run this thing without the need of the helper function to sort the primitive array type. So it's already 19 minutes and 21. Let us hit the submit button, and then we will see. And before it, let us hit the compile button to verify, and then we will hit it. So that is it. Let us hit the submit button as well. So great, all the test cases has been passed successfully. So let us end this video now, and we'll meet again in the tomorrow GFG POTD streak of day 162. And once again, I'm been consisting updating my trees playlist. I've completed the recursion playlist of data structures. Now I am on the trees. So must watch to understand how the recursion trees are going on, because those are the most complex topics. क्योंकि मेरे समय में था यार, मैं पढ़ के मेरे को कभी कभी नहीं समझ आता था, right? There are the things like Morris traversal, right, on and many more things, right, which may be asked in interview, because those are the standard DSA questions that are asked, if at all इंटरव्यू में पूछा गया तो, है ना? ठीक है, तब तक के लिए बाय बाय, टेक केयर, कीप ग्रोइंग, कीप लर्निंग एंड टेक केयर.